In this video, we'll be looking at part 3 of how to solve logarithmic equations. And if you're not subscribed, hit on the subscription button and also the notification bell for you to be notified when a new video is being released. Now let's start. So example 1, it says if log x squared is equal to log x all squared, find x. So we have our question as logarithm of x squared is equal to the logarithm of x all squared. So what we can do here is that we want to find x. So we work on the left hand side and maintain the right hand side. We are doing or adopting this strategy for us to find the value of x so easily. So it means that when we expand x squared, it simply means that is x times x. That gives us x squared, which is equal to the logarithm of x all squared. Now here we can see that they have been written as a single logarithm and they are multiplying, of which we can expand by using the laws of logarithms, which means that we are going to have here as logarithm of x plus the logarithm of x now equal to the logarithm of x all squared. So now we can see that there is log x plus log x, which simply means that they are being added. So when we add, we are going to get 2 log x now equal to log x all squared. So here we can group like terms by transposing log x all squared to the left hand side. So we maintain 2 log x and we bring that of log x all squared here, and now we equate to 0. So now once we have this, we can also expand log x all squared, and in that sense we are going to have 2 log x minus, so log x here being multiplied by another log x. Now we are equating them to 0. So once we have this, looking at the left hand side, we can see that there is log x, log x, log x running through, of which we can factorize log x out, which means that we have here as log x here into bracket 2 minus log x. Now we equate to 0. So this is how we can factorize. Now once we have this, then we can see that we can take it term by term, saying that when the logarithm of x is equal to 0, then by using the exponential, or that is changing from logarithm form to exponential form, we are going to have here as, remember that we said if you write a logarithm without the base, it simply means that it's in base 10, which simply means that this log x has a base of 10. So changing this to exponential form, then we are going to have here as x is equal to 10 exponent 0. And we all know that 10 exponent 0 is the same thing as 1. So it means x here is equal to 1. So this is the first term of it, giving us 1. Now let's focus on the other. The next one is when we have 2 minus log x to be also equal to 0. Now here we can group like terms. When you have 2 is equal to the logarithm of x. Now here we can write this as log x is equal to 2. So remember that this also has a base of 10, so we can bring it here. And when we change this to exponential form, then simply means that we are going to have here as x to be equal to 10 exponent 2. So basically x here is equal to 100. So therefore there are 2 values for x. That is x equal to 1, or our x here equal to 100. And this is how we can find the value of x in this logarithmic equation. So having known this, let's try the next example. So in example 2, it also says that we should solve log of square root of x is equal to square root of log x. So simply we can rewrite our question as the log of square root of x, which is equal to square root of log x. So here it means that we can work on the left hand side as well as we maintain the right hand side in order to find the value of x. So this is one of the approaches we are going to use. So we mean square root of x can be written as the logarithm of x exponent half, and then we have our square root of logarithm of x here. Now this exponent can be written as a coefficient to the logarithm, so this becomes half the logarithm of x, which is equal to the square root of log x. So here we can see that we can eliminate the square root at the right hand side by squaring both sides of the equation. So it simply means that we have half the logarithm of x all squared, which is equal to the square root of the logarithm of x all squared. So here we can see that this square is going to take away the square root, and on the left hand side, when half has an exponent of 2, then we have an answer as 1 out of 4, and the square root is going to affect the logarithm of x. So here we have log x squared, which is equal to the logarithm of x here. Now we can see that there is 1 out of 4 log x all squared is equal to log x. Now we can multiply through by the LCM, and that is 4. So it means that 4 multiplies 1 out of 4 logarithm of x squared, which is equal to 4 multiplied by the logarithm of x. So if that happens, we can see that this 4 can take away that 4. So you are left with the logarithm of x squared, which is equal to 4 multiplied by the logarithm of x. So 4 multiplied by the logarithm of x. Now we can also group like terms, and we have here as the logarithm of x squared minus 4 log x, which is now equal to 0. So just like we did, we can factorize log x out since it's common here. So you factorize log x out, and at this point you have log x here minus 4, which is equal to 0. So we can see that when log x is equal to 0, then to find the value of x, we must remember that this log has a base of 10. So changing to exponential form, then we have x to be equal to 10 exponent 0, which simply means that our x value here is equal to 1. So this is one of the values of x. In the same way, we can also say that when log x minus 4 is equal to 0, then we can say that our log of x is equal to 4 by transposing negative 4 to the right hand side. Here we know that this logarithm has a base of 10, so we write it and change to exponential form. We are going to have here as x is equal to 10 exponent 4, and 10 exponent 4 is the same thing as 10,000. So we are going to have our value for x as x being equal to 10. Then we have our 3 zeros, 1, 2, 3. So these are the values of x. Now you can now conclude by saying that x is now equal to 1, or our x value here is equal to 10,000. So this becomes the value of x in this equation. Now we move ahead and solve the last set of questions for today's lesson. So in example 3, it says that solve log 9 minus 2 exponent x base 2, all divided by 3 minus x, which is equal to 1. We are looking for the value of x if we have the log of 9 minus 2 exponent x base 2 divided by 3 minus x, which is equal to 1. So here, what we can do is that we have to cross multiply. So in cross multiply, then we are going to have here as the logarithm of 9 minus 2 exponent x base 2, which is equal to 3 minus x. So having known this, then we can see that we can change this logarithm form to exponential form. So we are using this very well. So it means here, changing to exponential form, then we are going to have our 9 minus 2 exponent x here, which is equal to, now the base 2 is going to have 3 minus x as its exponent if you are changing to exponential form. So simply means that we are going to have here as 2 exponent 3 minus x. Now at this point, we can see that when we look at the right hand side, we can write it. This has been written as a single logarithm, and we can expand by simply writing as 2 exponent 3 divided by 2 exponent x by applying the laws of indices. So once the bases are the same and they are being divided, we can write one of the bases and subtract the exponent, just like we see in the step above what we just wrote. So that's the reverse form of the second step, is what we have written at the third step here. Now we maintain 9 minus 2 exponent x. So here, we know we maintain 9 minus 2 exponent x here, and 2 exponent 3 is the same thing as 8. That is all divided by 2 exponent x. So now we have 2 exponent x here, 2 exponent x here. So to proceed, we can represent this 2 exponent x by a preferred variable, which means you can say let m be equal to 2 exponent x, which implies that wherever we see 2 exponent x, then definitely we are going to substitute m there. So 9 minus m is equal to 8 out of m. So here we can multiply through by the LCM, and that is m, and that gives us 9m minus m squared is equal to 8. So by grouping like terms, we have here as minus m squared plus 9m minus 8, which is equal to 0. From here, we can multiply through by -1 in order to make the coefficient of m squared positive. So that is m squared minus 9m plus 8, which is equal to 0. So when we factorize this, our factorized terms are going to be m minus 8, and we have here as m minus 1, which is equal to 0. So from here, we can now find the value of m. So it means that when m minus 8 is equal to 0, then our m value here is equal to 8. In the same way, when m minus 1 is equal to 0, then our m value here is equal to positive 1. So here we have two values for m now. But remember that we are not looking for m. The question said we should look for the value of x. So we have to quote, but we said we should let m be equal to 2 exponent x. So now if we are saying that, if we are saying our m value now is equal to 8, then it implies that 8 is equal to 2 exponent x. And this means that 8 can be written as 2 exponent 3, which is equal to 2 exponent x. So by comparing, or by looking at it, we can see that the bases are the same. So hence we can say that x is equal to 3. So that is one of the values for x. Also, we also said that one of the values of m now is 1. And we are saying that m is equal to 2 exponent x. That means 1 should be equal to 2 exponent x, which implies that we can find the value of x from here. Now we said a non-zero number of an exponent of 0 gives us 1. So it means 1 can be written as 2 exponent 0, which is equal to 2 exponent x. So here we can see that the base are the same, which also implies that our x value now is equal to 0. So from what we see here, we can see that there are two values for x. So therefore, x is equal to 0 or x is equal to 3. So these are the two respective values for x. So basically, this ends today's lesson on solving logarithmic equations. That is it, part 3. And so thanks for watching. Kindly like, comment, subscribe and share. See you in our next video. This is BakoMaths, thinking beyond infinity.